Today we're going to add two more rules to our list. So far we know the constant rule, the power rule, and the sum and difference. Today we're going to talk about the product and the quotient rules, and these are going to make finding the derivatives of various functions much easier than using the definition. The quotient or the product rule is derived in your book, so you can review that if you want to. I'm going to define it here. So given two functions, u of x and v of x, the derivative of their product is what I'm going to show you here. So if I say d dx of u of x times v of x, that stands for the derivative, here is what it is equal to. It's equal to u of x times v prime. So the first term multiplied by the derivative of the second term, and then to that I'm going to add the derivative of the first term multiplied by the second term. U v prime plus u prime v. That is the product rule, and I'm going to show you how this works with an example. So here we have an example. We want to find f prime of x if f of x is the product of two quantities. We have x squared plus 1 as a binomial and x cubed plus 3 as the second binomial. So here's what you do. I'm going to label each one of these with my two functions. I'm going to say u of x is x squared plus 1 and v of x is x cubed plus 3. And then I'm going to find the derivative of both of these, u prime of x, because here I can use the power rule. It's going to be 2x, and v prime is going to be 3x squared. Then you can put this together. My function, my final derivative, f prime of x, is going to be u of x times v prime plus v of x times u prime. So x squared plus 1 times 3x squared plus x cubed plus 3 times 2x. Now you have to simplify it down. You can't just leave it like that. So to do the algebra, I'm going to distribute the monomial into the expression. So we have 3x to the fourth plus 3x squared, and then I'm going to do the same thing here, and I have 2x to the fourth plus 6x. Combining like terms, I have a polynomial expression for the first derivative, and it looks like I have 5x to the fourth plus 3x squared plus 6x. And that's your final answer for the first derivative of f of x. So here's a different type of example using the product rule. We're going to let u times v, be the product of the function u and v. And here it is. F of x is equal to u of x times v of x. And then I give you numerical values for all of these things. u2 is 3, v2 is 1, u prime is negative 4, v prime is 2. So we're going to find the first derivative of f prime of 2 by just substituting in values. Remember, f prime of 2 using the product rule is going to be u of 2 times v prime of 2 plus u prime of 2 times v of 2. And then it's just direct substitution. For u of 2, we have a value of 3. For v prime of 2, we have a value of 2. For u prime of 2, we have negative 4. And for v of 2, we have 1. So our final answer, f prime of 2, is going to be, well, our almost final answer is going to be 6 plus negative 4. So it looks like f prime of 2 is going to be 2. That's an example of how to do this when you're giving numerical values and you have to use the rule to substitute in. Next is the quotient rule. The quotient rule has some similarities to the product rule. The first thing we need, though, is we have to assume a function is not equal to 0 because it is a quotient. So if we're given f of x is u of x over v of x, then here's what the quotient rule looks like. F prime of x, the first derivative, is going to be v of x times u prime minus u of x times v prime. So that order is important because we have subtraction in the middle. All over v of x squared. Now there's a way to remember this that I learned way back when I was in calculus years ago, and here's what we do. Since the v of x is in the denominator, we call that low, and the u of x is in the numerator, so that's high. And what you have is this: low d high minus high d low over low squared. Low d high minus high d low over low squared. Now that only works if you remember that you start low. You can't start mixing it up because then you won't remember it. Other than that, just remember it's the denominator function times the first derivative of the numerator minus the numerator times the first derivative of the denominator, all divided by the denominator squared. So we're going to finish with an example using the quotient rule. I have a quotient. My top term is x squared minus 1. My bottom is x squared plus 1. So I have low, which is the denominator. That's going to be x squared plus 1. And high is my numerator. That's going to be x squared minus 1. The derivative of the low, d low, is 2x, and the derivative of the high is d high, and that's also 2x. So here's my first derivative using the quotient rule. It's low d high minus high d low all over low squared. And we have a fraction that we're going to simplify. Typically, when we simplify, we leave the denominator in factored form. We don't multiply it out, because if we're lucky, possibly we will factor the numerator and have something that can reduce, but you never know. So in the numerator, I'm going to distribute. I'm going to be careful of the negative sign here, and we'll see what we get. So f prime of x is equal to 2x cubed plus 2x minus, I'm not even moving my parentheses yet, 2x cubed minus 2x, whoops, all over, this stays factored, quantity squared. What I would do next is I'm going to distribute the negative, and then try to simplify the numerator. So here we go. I'm going to distribute the negative into the parentheses, and it leaves me with f prime of x is equal to 2x cubed plus 2x, and now I have minus 2x cubed plus another 2x. You have to be careful when you distribute that negative. The denominator I leave in factored form, and you can see that my 2x cubed and my negative 2x cubed are going to add to 0. 2x and 2x are going to add together, and I end up with 4x in the numerator. So my final derivative, f prime of x, is equal to 4x over x squared plus 1, quantity squared. That is the first derivative using the quotient rule, and we will be practicing more of this in class.